Good afternoon, or good morning, or good evening, depending where you are listening today. Thank you all for joining me today for the 17th of our Columbia CBIPS lecture series on the AEC experience relating to COVID-19. I'm Fenioski Peñamora, Executive Director of Columbia's Center for Buildings, Infrastructure, and Public Space, and Edwin Howard Armstrong Professor of Civil Engineering and Engineering Mechanics at Columbia Foundation School of Engineering Applied Science. As the events of the last months have demonstrated, we are living during exceedingly challenging times, characterized by divides, distrusts, and distancing. However far apart we have been, however far apart we currently are, we need to learn to come together, to be together, to act together for social, economic, and environmental justice. I hope that the events of these days bring better understanding of the injustices that exist and become a catalyst to bring about real change for all. Along with many of our colleagues in New York City and around the world, the faculty and staff of the Center for Buildings, Infrastructure, and Public Space would like to add our voices to those decrying institutional racism in the AEC industry. Today, our industry has a challenging work ahead to achieve true racial and gender inclusion. We need to stand with our Black engineers, Black architects, Black contractors, Black suppliers, and Black community. We need to listen better, to learn better, and to incorporate the lessons of diversity and distress into the way we all, working together, reshape economically challenged communities. We need to build a better future for our industry, characterized by respect, opportunity, and collaboration. Acknowledging these aspirations and commitments, our lecture program will continue for the next two September Tuesdays at noon. The lectures bring people together to address the impact, response, recovery, and preparedness of the architecture, engineering, and construction community in regard to the coronavirus pandemic. These talks also relate to issues of social, economic, and environmental justice to the new normal post-COVID-19 AEC world. Our speakers were from Beijing, Boston, Chicago, London, Los Angeles, Paris, Sao Paulo, Seoul, Washington, D.C., Wuhan, as well as New York City. They all addressed the experiences of their offices in relation to COVID-19 impact, response, recovery, and preparedness. We have heard about public buildings, civic infrastructures, COVID-19 medical facilities, and changes in office operations. The talk next week by Columbia professor Karthik Chandra will focus on COVID-19 in relation to the epidemiology of water systems. Check our website to see more information about our next speakers and co-moderators. I also would like to thank the organizations with whom we are collaborating in presenting these lectures. They are the American Council of Engineering Companies, New York. I would like to thank Jay Simpson for all their support. The American Institute of Architects, New York chapter. I would like to thank Ben Prosky. The American Society of Civil Engineers. I would like to thank Tom Smith. The Consortium for Sustainable Urbanization. I would like to thank Lance Brown, who is joining us today as a co-moderator and respondent. The Construction Management Association of America, New York, New Jersey. I would like to thank Benny Falkowski. The Engineering News Record, I would like to thank John Tuckman, and the National Academy of Construction, I would like to thank Wayne Crew. Today, after provocative discussions on integrating technology on construction sites in China and Korea, we return to New York City to hear about how the AEC industry can create healthier buildings and shape COVID-19 design strategies. Our speaker, Douglas Maas, will draw upon his experience at Cosentini Associates to talk about how the pandemic has impacted the practice and projects of his firm. My co-moderator and the respondent today is Lance J. Brown, FAIA, President of the Consortium for Sustainable Urbanization. The CSU is a New York-based non-for-profit organization formed to promote a better understanding of the role of sustainable urbanization and resilient design in the planning of our cities. Lance is an architect, urban designer, educator, and author. He was president of the American Institute of Architects New York chapter in 2014, when his presidential team, Civic Vision, Civic Spirit, expressed his lifelong commitment to civic health and the importance of the public realm. He is ACSA Distinguished Professor at the Bernard and Ann Spitzer School of Architecture of the City College of New York. Previously, he served as Assistant Director at the Design Arts Program of the National Endowment of the Arts. His professional practice includes role advising the Lower Manhattan Development Corporation's World Trade Center site 9/11 International Memorial Design Competition and Boston's 9/11 Memorial Competition. His awards include the AIA New York State President's Award for Excellence in Non-Traditional Architecture and the prestigious AIA ACSA Topaz Medallion for Excellence in Architectural Education. Thanks, Lance, for being here with us today. Our speaker today is Douglas Mass, PE, President of Cosentini. Doug is internationally recognized in the design and construction industry because of his expertise as mechanical engineer, his commitment to design innovation, and long list of high-performance buildings projects designed by leading architects. His work in the area of LEED, sustainable design, has involved design commissions for both corporate and government clients who have sought his assistance on the development of building systems that are energy efficient, ensure occupant comfort, and promote the preservation of the environment. Doug's career spans more than 30 years and includes pioneering achievements such as the design of the first sustainable high-rise office building in Manhattan, 4 Times Square, and the first LEED Gold residential high-rise in the country, the Solar in Battery Park City. A significant current project is Shanghai Tower, which at 638 meters will be the tallest building in China. He's a registered engineer in 26 states and 2 Canadian provinces, and is a member of the American Society of Heating, Refrigeration, and Air Conditioning Engineering, the U.S. Green Building Council, and serves on the board of the Salvadori Center. To learn more about our speaker and co-moderator, please visit the CBIPS website. Thank you for being here with us today. Doug, the screen is yours to share.
Thank you. Let me just share my screen. Is my screen being shared?
Yes.
Great.
You can see it.
Thank you. Anyway, it's a privilege to be able to present today to everybody, and I'll go to the next slide, and you'll understand what we've been going through, obviously, as an industry. Let me see if I can get this. We've set up a task force, and we're part of a group. Cosentini is really is an engineering firm. We've been in business for almost 70 years. I've been there for 35 years now. And when the pandemic hit in March, we all sat around and said, we were receiving phone calls from clients, from end users, architects, developers saying, what do we do? And we said, well, it's bigger than us, certainly. And we said, this is about leading with science. So we put together a task force of which I'm a member, and many other folks in my firm throughout the US and overseas. But more important, we brought in some science. So we asked Dr. Bonfleth, who was the chairman of the ASHRAE COVID-19 task force, if he would work with us, as well as Dr. Kaiser, who was the head of Louisiana healthcare system. So we believe we have a lot of data here that we can present to everybody today. So let's talk about what the situation is. The situation we're in is that there's a virus called the SARS-CoV-2, and it causes the illness COVID-19. It's primarily transmitted through respiratory droplets, which are 5 microns and larger, and other modes may include aerosols. And this is very important because we all know what's happening with the controversy about going inside. May include aerosols and touching contaminated surfaces, although this is not thought to be the main way the virus spreads. Very little evidence that people have touched surfaces and gotten sick. So we need to rethink buildings and how people are going to be living in buildings in the future. So this is a quote from the Harvard Gazette, which really is all about the situation. It says, companies are coming back to work where workers have a heightened awareness about the risk of infectious disease transmission and how the buildings influence that. And again, back in March, I was thinking that all the buildings we all design today, what are we safeguarding? We're safeguarding against smoke, fire, earthquake, floods. Staircases have to be a certain width so people can get out. But what about safeguarding public health? And especially in the air and the air quality. It's not something that the industry is really focused on. And you will be seeing, in our opinion, more legislation and requirements on how to minimize any kind of infectious disease through the air in indoor spaces. So today we're going to talk about how do we respond as industry professionals to the people that will soon be re-entering buildings. So we've divided this presentation into 4 basic sections. First is awareness of the virus itself and the illness it causes, physical environmental design concepts that we as architects, engineers can influence in buildings, operational concepts, because a building that's not operated the way it should be will not help mitigate the situation. Of course, how do we influence safe social behavior? We actually update our presentation every day. We have a full-time researcher. Molly's on the phone. She does a lot of research for us, as well as our experts that we consult with on a regular basis. So as of this morning, as of September 1, which is now the seventh month of this pandemic, if you start with March, which is pretty interesting, there's 25 million confirmed cases worldwide. And they believe that's about 1/10 of the actual number of real cases, because many people, we all know someone that probably had it but didn't or couldn't get tested at the time. And I remember working in China, we mentioned Shanghai Tower, and even prior to that, we were working in Beijing, I remember in Beijing when the SARS virus hit, and everybody was very, very panicked and concerned. There were 8,000 confirmed cases versus 25 million. Big difference. So we'll talk a little bit about the virus itself. The SARS-CoV-2 virus size is between 60 and 140 nanometers, and gives you an idea. The flu is about 100 nanometers. The rhinovirus, the common cold, is 30 nanometer size, and it gives you an idea of the section of the human hair and how small the virus is. So how is it transmitted? And the primary transmission method is from person to person in close contact. And we talk about respiratory droplets, and the way to visualize it is a droplet is something that will, when you talk, when you cough, when you sneeze, it's a droplet that they're saying is about 5 microns or larger, and it's heavy enough that will fall out of the sky, will fall to the ground within about 6 feet or 2 meters from somebody. And that's sort of the rule of thumb we've been using as an industry. An aerosolized droplet, the way you think about that is as the droplet comes, as the droplet goes into the air, it might start evaporating slightly, and all of a sudden it gets smaller than 5 microns and becomes buoyant, which means that the gravity will not pull it down because the air currents are strong enough to keep it afloat. Or you could think of it as almost like a fog in the air. And of course, the concern is as the winter comes, will these viruses and will these droplets be traveling farther because they become lighter as they start evaporating into the drier air. And the third method they talk about is fomites, or basically a surface mounted or surface formed virus. And again, we know that the viruses can live on surfaces, but again, very little evidence that people have gotten sick touching surfaces, although we still should be very vigilant and keep our hands washed and surfaces clean. So the 4 main elements to consider, and then I talk to everybody about this, whether I'm out at the store or my family. The 4 things that we really need to be aware of is, one is maintaining distance and wearing a mask. Second, be in a well-ventilated environment. Outdoors is ideal. Opening the windows in a very, very large space. Try to stay out of small spaces. Limit the time you're with somebody. And of course, the activity level, singing, yelling, produce more viruses. So if we follow these four rules, we will hopefully be safer. Why are we even having this discussion today? It's really because of this first sentence, which I will read. Those infected with the coronavirus are emitting the virus before they're symptomatic. And that is the issue. Science is saying 2.5 days prior to having any symptoms, you can start spreading the virus. You're infecting others potentially. And around 18 hours prior to you're getting a symptom, you may be the most symptomatic or most contagious, excuse me. And they estimate 44% of transmissions occur from people who are in the pre-symptomatic period. Meaning if someone seems well, you should still maintain your distance because you don't know if in fact they have the virus. So the transmission of any virus or any illness is something called an infectious dose. How much of the virus is necessary to make somebody sick? And it is unknown for the SARS-CoV-2. It obviously depends on your immune system and other factors. So what we talk about is the activity level. You certainly want to be in a lower infectivity kind of zone. So it gives you an idea of someone that, and these are stats that were done for the flu virus. They say it's unknown for the SARS-CoV-2, but it's believed that the SARS-CoV-2 will behave similarly in terms of transmission. So breathing, you might have, if you're pre-symptomatic, but you have the virus, up to 33 infectious particles, and if you go and fewer droplets. But if you go over to coughing or sneezing, you could have millions of infectious particles, which is why we all need to wear a mask, not just to protect ourselves, but to protect others. So let's talk about ASHRAE'S position. ASHRAE, for those who don't know, in the HVAC world, that the standards that we use to design systems are based on ASHRAE. Similar to architects might use AIA, we work with ASHRAE. ASHRAE's position is pretty clear. They're saying ventilation and filtration provided by the HVAC systems can reduce the airborne concentration of the virus and thus the risk of transmission through the air. There isn't a lot of evidence that you will get the virus going back to, let's say, a central system, and then it goes out and spreads throughout the building. However, they do know that the virus can be airborne, and it's our job as engineers to minimize and try to remove the virus in the airstreams. So today we're going to talk about four basic areas: HVAC systems, architectural systems, mostly frictionless, how we can go in and out of buildings without touching surfaces; materials, we want to have low VOC materials to promote good health; and of course technology. Technology will help foster all of the attributes that we're going to discuss today. So, I talked about the virus itself, and the dilution of the virus is very important because the higher the concentration of the virus, the more viruses you breathe in, the greater the chance of you getting sick. So from an HVAC standpoint, the things that we want to do is, number one, we want to dilute the virus. How do you dilute it? You bring in outside air. You want to sort of dilute it. So how do we do that in buildings? We might increase outdoor air ventilation, disable demand control ventilation. Demand control ventilation is a technique that saves energy. If there are less people in the building, you bring in less outside air. We're saying for the time being, we're asking our clients to disable it. Extend hours of operation. Run your HVAC systems prior to and after occupancy, just to continue to dilute. And then in small spaces, small conference rooms, et cetera, you might put a CO2 sensor, which could alert the HVAC system to bring in more outside air, should you have that capability. So the first thing we've done, we said we've diluted the contaminant. Now, when it goes back to the HVAC system and it wants to get redistributed, we want to remove it. How do you remove it? You use filters. And we're going to talk about filters in a moment. There's also techniques to disable the virus, the airborne virus. And we'll talk about air ionization, which is not thought to be a system that will actually disable it airborne. It's quite controversial. We'll talk about that. And also UV. UV is, in fact, very effective, and we'll describe that in a minute. Air exchange, containment. How about smaller HVAC zones? If you have a smaller zone, less chance of the air being distributed to another part of the floor. Bathroom exhaust, we're saying increase it. Why not increase bathroom exhaust beyond where the standards are today? It's probably a good practice to do anyway. It could be helpful. And elevator ventilation. We're working with several elevator manufacturers, and they are providing additional air changes in elevators and perhaps some other techniques to disable viruses. And controlling pressure relationships between spaces is important. And lastly, humidification. Humidification is very important to keep us healthy. We'll discuss that in a minute. So here's a chart with a lot of numbers, but I will simplify it, and I think it really is important to think about. A typical modern building, Let's talk about an office building. In a typical modern office building, the air in the space that you're in, and many of you probably are in an office space now, it takes 60 minutes based on code fresh air that you bring in, 60 minutes to change all the air. So the air is replenished only once an hour, yet it goes back to the air handling unit and it's filtered 6 times an hour. So thinking about it, it's filtered quite often, 6 times an hour, but it's only refreshed fully once an hour. So one of the things we're talking to our clients about for the time being is what if you double the outside air? Clearly the math is simple. Then every 30 minutes you replenish the outside air. It's still filtered 6 times an hour, which is why filtration is so important. And we've analyzed the energy implication. Obviously, more outside air, more energy you're using. And we've also analyzed 1970s buildings, different style buildings. But this gives you an idea why filtration is so important. What is a filter? A filter is basically a series of interlaced glass fibers that capture particles. So the denser the filter, the smaller the particles captured. Very, very small particles in the size of a virus have a very erratic kind of motion, and there's something called the Brownian motion, where these particles do not follow a straight track and they can get trapped. And that's why you'll see small particles are, filters can be very efficient on viral sized particles. Promised the last chart with numbers in it, but this is the basic ASHRAE filtration chart. And I'm sure you've all heard about MERV ratings, and MERV ratings have to do with the efficiency of the filter, the size particles they remove. MERV 8 to 16, and then when you get into 17, 18, 19, 20, in the blue here, those are HEPA filters. Those are hospital rated filters. And filters are rated in basically on what they're trying to capture. So what we're saying is the smallest particles that they're rated for today is in the 0.3 to 1 micron range. Even though the virus is smaller, it can get trapped because of that erratic motion I mentioned, the Brownian motion. So ASHRAE is saying, let's upgrade to a minimum of a MERV 13 filter. And you know, our office's position is if we get a 14, it's better than a 13 and will have very little impact on energy consumption. So we'll go to the next slide and I'll tell you why that we think 13 and 14, and that's what ASHRAE is saying, is good enough. This is a chart that shows a study that is this axis is the rate of infection by the flu virus. Again, we mentioned before, they don't have a lot of data on the SARS-CoV-2, but they believe it mimics the flu virus in many ways. So this is the risk of infection, and this is the filter type. And if you notice, without a filter, they're saying about a 25% risk of infection in an office space. And as you go from no filter to a higher efficiency filter, it continues to reduce until you get to about a MERV 13. And if you notice, the MERV 13 filter is around 14% risk of infection. And then as you continue to get more and more efficient filters, the rate does not drop appreciably. And that is because there are enough of the viruses in terms of the flu virus captured by a 13 that they feel that the risk does not really go down that much if you improve your filtration. And this is a chart that shows the cost of filtration, because you have fan energy, because the higher the more dense the filter, the more energy you need to push the air through, the filter cost and the labor cost to replace it. And as you can see, a MERV 13, MERV 14 are about the same price. And then as you go up toward a healthcare HEPA filter, the cost goes way up, which is why ASHRAE is saying MERV 13 and 14 is what they would recommend. Now I'll talk about ionization. Ionization is a technique which creates ions, positive, negative ions in the air. They attach themselves to dust, mold, spores, and even viruses, and they cluster together. And what the theory is, they fall down because they become denser. They become larger particles that will get captured in filters. And the manufacturers maintain, and the manufacturers' studies are saying that the ions attach themselves to the protein shell of the virus itself and can penetrate the shell and disable the virus. Now, ASHRAE's position is pretty clear. They're saying that the systems could be ineffective to very effective, but there have not been enough peer-reviewed studies that are independent to really recommend that technology. We've used it for allergies, molds, to clean the air for odors, etc. And it's something that you can think about in your buildings, but it's something that's still, we're waiting for ASHRAE to come back with more firm recommendations today. When you can put them in buildings, one of the things that they can be done, they're very little pressure drop. You can actually retrofit. This is a controller, and these are the tubes that create the ions in a duct on a discharge. This is a unit that's in an individual unit, like a heat pump in a building. So let's talk about air treatment and UV light. UV light sanitation has been around for over 100 years in terms of a science. It's used in the water industry. It's very, very effective. But UV lights, to be effective, you need to have exposure time. So the effectiveness is based on how long the air is exposed to the UV, or residence time. And there's something called the dose. The dose has to do with the intensity of the light times the time that's exposed. So if you're in a duct system and the air is going very quickly, it's hard to get a lot of disinfection because you don't have a lot of contact time. The electromagnetic spectrum, as you can see, the most germicidal or effective wavelength is 265, which is in the UVC, which is not something that you want people to be looking at directly. So we've used these in duct systems. You will also talk a little bit about other systems. Columbia University actually is researching far UVC, and there's other techniques we'll talk about. So I mentioned to you, in a duct system, if you were to put UV lights in a duct system where the air is traveling very quickly, you need a lot of lights for a long distance. They are used effectively. This is a cooling coil, and these are these UV lights in a cooling coil used in the healthcare industry quite a bit to disinfect the cooling coils, which are usually damp when they're disinfecting, when they're dehumidifying, excuse me, and these lights will kill molds and spores, and you can get UV that can be very effective at a high intensity against the virus. So it's something that we're looking at, and depends on the application with our clients. Other types of UV, there's something called upper room UV disinfection, which is used in the healthcare industry, where the light, the UVC light, and I mentioned too, you don't want to shine on people's eyes, it shines up against the ceiling. And why it's effective there is because the velocities are very low. And you have natural convection here, so it will do a good job of disinfecting. Generally, we're recommending above 7 feet, so people do not get a direct line of sight. Also, you have to be careful with the reflectivity, because if you shine the light up and there's a reflective surface, it could shine down on people. So it's something that can be very effective as upper room. Other types of UV light sanitizers, you might have seen these on television. I think Amazon is using these in their fulfillment centers for Whole Foods. But these are high intensity units that are used in the healthcare industry. They're very expensive. But what's important to note is you need line of sight. So the back of this monitor would not be disinfected unless this unit were moved or there was some reflection on that surface. And these are other types, as pulsed xenon lamp types. There's a lot of different types of UV that's out there today. One of the things that we're talking about as an industry is UVC lights in an unoccupied space, an office space. We're also talking with a manufacturer about pendant mounted lights, where the where the indirect light might be a UV and the direct light might be a light at a visible wavelength. Again, we're looking at the safety as well. Far UVC, which I mentioned is being researched at Columbia, as well as there's an LED technique that's being researched in New Zealand today. And again, the position is we're waiting to find out about the harmful effects on occupants, also on how it does disable viruses because it's at a lower spectrum. Conference rooms, small spaces. What we're recommending is putting in a local filter. This happens to be a DFS system. It's a very effective one, which is a HEPA filter. This is actually from my office space. This is a V-bank HEPA filter, which they put an electronic charge across it, and it can remove particles down to 0.007 microns, whereas the virus is at 0.1 micron. Again, something that is on the market that you may want to look into. Other technologies, DHP, dry hydrogen peroxide. It's being used at MacArthur Airport, other spaces where they do fogging. Again, there's a limit. Going above 25 parts per billion in the air could be harmful. So it's something that has to be used very carefully. So sort of an air treatment option summary. When you look at what you're treating the air for, you have to decide what you're guarding against. And if you go to viruses, what we're saying is getting a good high efficiency filter will do a very good job. Ionization, we believe it's good on surfaces, but the science is not there yet to say that it's effective in the air. UV lights, we think they're very good. Again, you have to have a contact time, and people have asked us about carbon filters. Carbon is really much better for odor control and off-gassing. Humidification. Humidification is very important, and we of course have an issue in the Northeast where it's very cold, and our building facades cannot afford us to do a lot of humidification. There could be other effects that will hurt us if we don't do it properly. But maintaining a 40 to 60% indoor environment may help limit the spread and the survival of the virus for a few reasons. One, higher humidity reduces the infectivity of the flu virus. So this is a chart for the flu virus, and again, we're saying that the SARS-CoV-2 would mimic it. In fact, they have done some tests, and they've shown that at about a 20% RH, that the half-life of the SARS-CoV-2 is 3 times what it is at 40%. But this chart basically shows the infectivity rate of the flu virus around 70%. When it's dry out, 10 to 30% RH, and notice it reduces substantially at 40%. And this is an optimal zone chart that's been around for many years for viruses and bacteria. The second reason is the membranes in our respiratory tract and our nose dry out in the lower humidity, and that's our first line of defense. And then something we talked about early on, we talked about droplets versus aerosols. Low humidity results in breathing smaller particles. So those droplets will immediately start evaporating, and they'll travel farther because they become buoyant. It's just something to think about. Zoning in a building. A very simple illustration, and then I'll go through a case study. Let's make believe this is a full floor. Could be an office space, and I have 2 air handling systems. One serves zone 1, one serves zone 2. Versus taking the same floor with systems that we're using today, there's something called a VRF or a DOAS system, where I might divide that zone into many, many different spaces. So imagine somebody's in zone 4 and they're sick. The air is only recirculated within zone 4. So that's a positive thing. So it's unlikely someone in zone 1, 5, or 6 would get sick. The amount of outside air that goes into these direct outside air systems or DOAS systems is fixed, so you'll get good dilution in here. The downside is it's more difficult to get a better, more efficient filter in these small units because they don't necessarily have enough horsepower or static pressure to push through. If I go to a standard operation today where I might have a unit serving the entire floor, if somebody is sick, all of the air goes back to the main air handling unit. But at that air handling unit, I can most likely get a very, very efficient filter, maybe a MERV 13, MERV 14, which should do a good job in removing a lot of the viral contents. So you can see there's an advantage to both systems, and we just have to be wary when we design to make sure that we ensure we have a right amount of ventilation air and the best filters we can get. So this is an illustration of an outbreak that occurred in Guangzhou, China in January. And again, when we think about this, we're only in, well, today's September, but this is all recent. And normally when we study pandemics and other things, it's going on for years. So what happened at the restaurant is very interesting. There was somebody at this table. This is a floor plan, and these represent tables, and these are chairs. Someone at table TA was sick, pre-symptomatic, a super spreader, they call that person. And there were 10 people that got sick among these 3 tables. No one got sick at the green tables, and none of the wait staff that went in and out of the space got sick. There was an outside air damper here, and they said the outdoor path went this way. There was really no proper ventilation system, and on the wall they had 4 wall-mounted split units. So basically what happened is this, and I'm on the right side here with the cursor, the study said that there was maybe a 10th, I'm a seventh of the outside air that we would recommend as a minimum. So virtually they had almost no outside air. There was some outside air in this zone, and it's unlikely there was any, if any, in this zone. So what happened is this person got sick, and this unit just kept recirculating the air. They had virtually no filter. They have these washable metal filters that come with these units. So the concentration of the virus continued to rise in this area. It probably became aerosolized, and people got sick because there was enough, there was a higher enough dosage. They did a CFD and a tracer gas analysis, and if you can see the light blue here, they found viruses in this area, but it was not at a high enough concentration where people got sick. They also found that the people at table TA and TC were exposed to this person from 50 minutes to 75 minutes. I don't know how long the people in this area were exposed, but let's assume it was a similar amount of time. So what is the takeaway? Smaller zones are better. However, you need to have proper filters to remove, and you need to have proper outside air to dilute. So we've gone through the engineering portion. Now we'll talk about sort of the architectural and really more about the touchless world. So we'll talk about doors and entryways, pantries, bathrooms, and then we want to have automatic lighting and shades. And what we think about is, I always think about, and in our office, green, yellow, red zone. I hope everyone who's on this podcast today is in a very safe zone. They consider it a green zone. All we can influence as an industry is what we do from the door of our building throughout the journey in the building. What the public transportation is another issue. So what we would like to see, we'd like to see automatic doors when you enter a building. We'd love to see an entryway mat to disinfect your shoes, a sanitation station to disinfect your hands, some type of barrier or a screen where there's security or reception desks. Now, if you have a high-rise buildings with elevators, you have to get into the elevator lobby. You can use facial recognition. You can use mask scanning today. There may be thermal scanning in the future, but we believe it should be a touch-free system where if you have an app on your phone, it can recognize you, or maybe an optical scanner for your card. And of course, in a building lobby, enhanced HVAC. Now you go into the elevator lobby, and I'd say we're going from green to maybe a little bit of a yellow zone. We're a little concerned. Minimize elevator occupancy, clearly. And that's another discussion, which you may want to have someone talk about elevators. Consider UV or HEPA filters in elevator cabs, and we're discussing that with elevator manufacturers, and now we're increasing the ventilation. Now you're in the elevator lobby, touchless destination dispatch. You don't want to touch the pad. And of course, let's keep the elevator doors open whenever they're idle, sitting on a floor, so we can dilute what might be in there. So now we've gone up to our office floor, we've increased the outside air, we've enhanced the HVAC, larger workstations, staggering work hours perhaps. For conference rooms, let's space out the seating, but also let's add some CO2 sensors and consider portable air filtration to do a good air change in there, and also make people feel more confident. Floor markers for circulation and 6-foot separation, and of course, desk dividers. We put these in our office, clear ones. They look really nice, so you don't have to necessarily wear a mask at your desk, which is becoming controversial, but certainly you want to separate people. So now we go to the pantries. Education is very important. This is in a pantry area. You might want to put your hand washing education posters. What about taking your motion activated faucets and putting a 20-second timer on it so the water stays on for 20 seconds so you'll properly wash your hands, or maybe wash out with a mug or whatever you're using. App-based coffee machines and water bottle fillers, touchless cabinets, and recycling. You want to have open countertop cutouts for recycling. Bathrooms. Increase bathroom ventilation. I talked about that before. You want to have, and plus as an industry, we probably should increase bathroom exhaust. It has not been great in our industry for many years. Consider full height toilet partitions with proper ventilation. What about lids on toilets? What about UV disinfection in toilets, perhaps in the future? Automatic flushometers. And we're discussing as an industry, maybe UV for after hours disinfection. It might be a good idea to do in bathrooms anyway. 20-second, I mentioned 20-second automatic faucets, which, and we've checked with most of the manufacturers, and you can either through a program, through a wireless program, or manually adjust them so they stay on longer. automatic paper towel dispensers, open trash can located by the door, and disable air dryers. And when you leave, an automatic foot pull or some way of having an automatic door. So now let's talk about operational concepts, things that building owners need to do. Because we could talk about all these great systems and ideas, but if they're not working, you're really not any safer than you would otherwise be. So let's talk about cleaning. New cleaning procedures, more deep cleaning of spaces. What about cleaning out air handling units that have not, for areas that have not been occupied for many months? Also, we're talking about what about floor drains in bathrooms that maybe the trap is dried out. So there's a lot of things we could talk about in buildings. Air quality, want to change filters regularly, monitoring air quality, extending the ventilation hours I mentioned before and after hours with outside air. Screening protocols, are we going to use thermal scanning? Thermal scanning is a great technique, but as we mentioned before, it will not help if someone's pre-symptomatic comes in the buildings. Staggered arrivals and departures. And what about packages? Are we going to be putting them in isolated rooms? Are we going to put in UV in there? And that's something that needs to be discussed. Commissioning, what we think is very important is, we're going to a lot of buildings. The industry is, you saw today, I think de Blasio was at some schools checking on HVAC systems. They need to be commissioned. You need to make sure they're working as intended. You need to train the operation staff so that they can maintain them. And then in buildings where you have multiple users, there needs to be a best practices manual for the people that occupy the space as well. So we all abide by the same rules. Thermal scanning, something I wanted to show. You can have facial recognition, but there are thermal scanning systems today that can be purchased, and you can retrofit turnstiles for that. And there's something called large volume scanning, which I've experienced when I've gone overseas to China and Asia. It's used quite frequently there, where as you're walking through, they have scanners, and if you have a fever, you have a problem. And smart building workplace management is very important. This is the app from Edward Lee's phone. Edward is in the Shanghai office for us, and he said when he came back from Los Angeles in March he was visiting Los Angeles, the barcode turned yellow, which meant he couldn't go into his office building or in his apartment building until it turned green. He had to self-isolate. This is from our Australian partners, Stuart's phone, called COVID Safe, a voluntary system of contact tracing. So we'll see a lot of these new techniques. You're seeing them in universities today, and they're as good as people are willing to embody them. So if you don't turn your phone on, you don't have your phone with you, you don't have your Bluetooth on, they don't do any good. But it's something in society we're going to have to deal with. So I think in conclusion, we have just two more slides. One is, what we're really saying is we want to maintain the safest building we can. One thing which is important to note, HVAC solutions cannot prevent person-to-person transmission. All we can do is make the buildings as safe as we can. So I want to make sure everybody understands, by doing the filters and everything we've talked about, nothing will prevent, at this point, person-to-person transmission if you're not wearing a mask and not distancing. So we're saying social distancing is very important. We need to promote that. Education, people need to be educated. Going digital, we're all doing that right now. Obviously, it's something that many of us wish we weren't going digital, but it's something that we're going to be doing for a long time. And of course, the new protocols, how you deal with each other in a safe and respectful environment. And then what we did is put together a very, very simple kind of conclusion from a mechanical engineering standpoint, of the things that we think we should consider. And this short-term versus long-term. And what we mean is, and we discuss this a lot with the architectural community and engineering community, what will stick and what won't stick. And we think that viral contamination in the air is something that we're always going to have to be aware of and have to safeguard against. Social distancing, I'm not quite sure, but there are things that we're going to talk about. So certainly outside air, we're saying bring in extra outside air, purge before and after. And we believe, and I could be wrong, it's a prediction that ASHRAE is going to say we should be at the lead rating, increase their minimum standards by 30%. That's something that we believe may happen. Filtration should be 13 or better. And we think that long-term, they're going to recommend a 13. Humidification, we'd love to do it in the Northeast, very difficult. Proper treatment of restrooms we think is important. The local filters in small spaces is something I think is important. We're also talking to the restaurant industry about doing this in order for them to open indoors. And of course, the touchless world that is going to be based on apps and smart buildings. So with that, that's the conclusion of my talk today. So I want to thank everybody and open it to questions.
Thank you, Doug. Lance?
Yes. Doug, in terms of questions, I have one that I'd like to start with. Let me start. First, Fenioski, thank you very much, you and Rick, for putting this whole series together, including this very wonderful, insightful, detailed, and timely four-part talk by Doug. Beautifully done. Thank you.
Thank you.
And also, before my first question, I'd like to invite everyone, thank you for the CSU mention, Fenioski, to our Consortium for Sustainable Urbanization October 5th United Nations World Habitat Day program on post-pandemic cities, and our Consortium October 7th Claire Weiss lecture on millennium thinking. You can register for both of these via the AIA New York calendar or visit us at consortiumforsustainableurbanization.org or csu.global. My plug over. It's a sincere invitation. A first question I would like to ask is based on a conversation I had with a colleague just yesterday, representing a 300-person office in Midtown Manhattan. She said that her existing six-person conference room can now only have 2 people. They think it might as well be a private office for that. And that their 24-person conference room now is rated for only 6 people with what we call social or physical distancing and the rules that they're working with. So she's wondering, of course, why even return to the office with such restrictions? My question derived from that would be, or her concern, is there a way, perhaps with all the approaches that you've offered in your discussion, plus combined with a more personal protective system or device, a mask, a face shield, fishbowl helmet, that would allow for these previous sized meetings to take place in those spaces, and your prediction of same?
Great question. I'm asked that a lot. I mean, clearly if somebody was wearing a moon suit, like a space suit, maybe you could, but the real world is, unfortunately, at this point, there is, I said earlier, there's no mechanical system that can prevent person-to-person transmission. So in small rooms, what's being recommended is, because let's say I'm in a small room and I am infectious, there will be viruses in the air even if I have my mask on, because masks leak. So maintaining social distancing is very important. What we are recommending in small conference rooms is putting in a local HEPA filter. Even when they said she could only put 2 people in, we're recommending you put a small filter in. And I'll tell you why. The small rooms generally are quite constrained, lower ceilings perhaps, maybe without a window. And we feel by having a unit with a HEPA filter, which we're very readily available at 4 air changes, which is easy to calculate, it will give you a sense of comfort in there. And as long as you don't spend too much time, I think it would work well. But no, I don't believe we can go back to full occupancy based on a quality HVAC system.
Okay, if I could just follow up with that for 1 second. We are told that sitting in an airplane these days with a certain amount of spacing is not the most dangerous thing in the world. Is that not, and is their airflow system not something that might be adapted to buildings, or are we still at greater risk in those airplanes?
Well, I think in airplanes, and you've all probably read on United or JetBlue and seen their videos, they have very sophisticated HVAC systems. So if you're sitting by the window, the number of air changes that they have, and there's 2 types of air changes: there's outside air and there's recirculated air. They use HEPA filters, and I believe an airplane is probably a safer place to be in if you're by the window than you are in a conference room if you're going to be in a conference room for a long period of time. But the air industry is relatively safe.
Okay, thank you.
Well, I just want to thank both of you, Doug and Lance. Doug, your presentation was very illustrative. You provided a very comprehensive view of the situation from kind of the beginning of the virus to the actions both. And I really like the way that you kind of focus on the technology, but also focus kind of the operations and the human side. You can have the best technology in the world, but you still have to have procedures in which we all can ensure that as a community we are safe. And I think your answers to Lance, it goes back to that issue of we as a community ensuring that we follow protocols to keep all of us safe. We have a question following up in the technology area from Andrew Bergman, who is asking, what about the use of underfloor air distribution? One of the issues is that it's considered a solution that can overcome some of the limitations of overhead distribution by mitigating the spread of aerosol particles within offices because of the move in low velocity at the low level and kind of rising as a one-pass motion. And, Andrew would like to know your thoughts about that particular approach.
Sure, great question, and we look at that quite often. Underfloor air distribution systems are very effective for two reasons. One is something called ventilation effectiveness. Ventilation effectiveness is really defined as what % of the outside air that you deliver gets into the breathing zone. Mm-hmm. And since it's coming from the floor up, it's almost 100%. An overhead system, sometimes you get short circuiting. So number one, it's effective because you probably have higher dilution where you are. That's number one. Number two, because of displacement, basically it goes vertically up. So it's less likely that if I'm sick, that the person 2 stations away might get or 3 stations away might get the virus. Having said that, and we've posed these questions to our subject experts that consult with us from ASHRAE, and there's another comment which was quite interesting, and that is if I am sick, the general area around me will have a higher concentration of virus. So if you're sitting 6 feet away from me, you might be more likely to get sick because there's a higher concentration where you are than if I had an overhead system. So I think statistically, if we really ran a CFD model of it or did it in tracer gas, you probably see underfloor would probably be at an advantage over overhead. However, we know, 90%, 95% of spaces are overhead. And most of the underfloor we've done are in headquarters buildings. That's a great question. And again, it's what happens is we get asked questions all the time. And anytime we present, it's common sense. Because, when you're walking down the street, you see somebody, you're in a room, you're on a plane, you're thinking about where those viruses might be. That's a good question. We like underfloor distribution for that reason.
Thank you.
I would like to follow up with another issue that surfaced from my experience by listening to New York City's Department of Transportation Commissioner Polly Trottenberg, who was talking about basically New York City's public space, if you would. The space between buildings, the space that we landmark when we landmark a district, the outdoor rooms of the city, which, as we know, are quite rich when you begin to dissect them in terms of their parts. So she was discussing how wonderful the streets were occupied by European-style restaurants and how joyous whatever that amount of activity could bring to what otherwise is a difficult time. And then she got into the seasonal issues, which from a transportation point of view was how are we going to get rid of the snow if there are restaurants out of doors? And an observation that the French, who have traditionally used outdoor propane heaters to turn the outdoors indoors, She said that they had recently outlawed those, made them illegal, that the idea of using energy to heat the outdoors during the winter was counterproductive. I don't know what they will do with their cafe society, but basically it raised the issue of how everything that's kind of at that public ground level, that's generally on the street, on the sidewalk, in the lobbies that you referred to, and deeper inside, the seasonal. You know, we could talk long-term, short-term. I'm talking about the seasonal issues that are part of, I think, what your bailiwick in this conversation is. And do we build tents over sidewalks? Is that a medium sort of semi-outdoor? Is there something we will do inside these restaurants and museums? And I know it overlaps, and I know there's vagary in all of that, but whatever thinking you may have done, I guess especially in New York City and other basically pedestrian, walkable cities, you know, that place, that our stores, our markets, and what we can hope for them to make them occupiable in an economically survivable way.
Well, it's, if you said, I have a budget and time, we can create very safe spaces that are, let's call them indoor-outdoor spaces. The reality is, and we're working with the restaurant industry right now, the city, there is a memo, I think it was 7 years ago, about outdoor dining using propane. And right now, you can't use it outdoors. As far as we know, you can pipe natural gas to heaters, which is unrealistic. You can't afford to do it. And by the time we do it, the restaurants will be out of business. So we're looking at electric radiant heaters. The idea was, how can we extend the outdoor season? How can we extend it? We're looking at electric, but where do you get the power from? And we're looking at, is there a safe way we can use propane? Because you can rent and get propane very quickly, but there's a safety issue. And coincidentally, we're in the midst of that discussion right now, because right now it's September 1, and you know, in 2 months, will we be able to eat outdoors, and will indoor restaurants be open? And that's another challenge.
Yeah, I know that New York City by Design, working with the AA and others, is looking at this very carefully. Obviously, I think even with some pro bono services for those restaurants that are having a hard time, you know, making ends meet, but with a desire, New York City by Design, to keep that industry alive, both for our general well-being, certainly our health and welfare, but also, you know, the joy of living. So hopefully the work you'll do with them will be successful.
Thank you. And that's a very good point. You're going, like Lance, what you mentioned, the joy of living. And now people have covered that the outdoor space is a place where they can make it their own. So I can understand the challenges and the tensions that will occur now in cities. I would like to ask our last question is from Eric McFarland, the Deputy Commissioner of the Department of Design and Construction in New York City, and one of our speakers. He was trying to find out, besides mechanical system upgrades, is there any particular ideal concentration on the number of people that can occupy a space? You know, right now they're talking about 30%, 50%. Are there any proportion in terms of the space, or it just depends on the type of space that will have to be considered?
I think the answer is, it depends. Okay, and there's no scientific answer right now. You can model any condition that you want, and I will just to add, because I know we're running out of time, is I mentioned that our task force and our commission, every week we meet on Thursday evenings, Eastern time, because we have people from around the world that join us on our task force, and we ask questions of Dr. Bontleth and Dr. Kaiser and others. So if there are questions that anyone listening today would like to know, that we can research, and you know, I'd be happy to present it, and hopefully we can get an answer, because anytime I do a presentation, I learn as much from the feedback as what we talk about. So I think this is, as we said, this is bigger than any of us, and we really need to deal as a community. So please feel free, if I don't know if my email's there, but if people want to email me with questions, if I can answer them, I will. And if I can't, I will do my best to get the answer.
Thank you both, Doug and Lance, for a wonderful presentation and insightful questions. We really appreciate your time and sharing your knowledge and your expertise. We also would like to thank our collaborating organizations, ACEC New York, AIA New York, ASCE, CMAA New York, New Jersey, ENR, NAC, and of course, CSU. I know that some of you through the chat have asked about the conference and the symposium that Lance mentioned for the Consortium for Sustainable Urbanization. Please visit their website at consortiumforsustainableurbanization.org, all in one word, consortiumforsustainableorganization.org, and the events are posted there. I also would like to thank some of our past speakers and past commentators that have joined us today. We have Dick Anderson, the President Emeritus of New York Building Congress, Wayne Crew, the General Secretary of the National Academy of Construction, of course, Eric McFarland, who I just mentioned from DDC, Jerry Buckwalter, Chief Operating and Strategy Officer at ASCE, who is actually going to give us the series finale, the last presentation lecture for this series on September 15. Natalia Valencia, the President of the New York City Architecture Biennale, Yves Michel, Vice President of Development and Chief Architect at Metropolitan Transportation Authority here in New York City, and Hao Xin Pao, Assistant Commissioner of Design at New York City Department of Design and Construction. Also, we'd like to thank all of you out there in the offices, agencies, and at home throughout New York City and around the world for taking time to listen today. Continuing education credits for architects have been requested. If you are seeking credit, please send your name by email to cbips@columbia.edu. I also would like to thank the team at Columbia Center for Buildings, Infrastructure, and Public Space, Michael Smith, Charles Cheng, and Rick Bell, with whom this program would not have been possible. The next speaker in this series on Tuesday, September 8th, the 18th lecture in the series will be Dr. Karthik Chandran, Professor of Environmental Engineering at Columbia University. My co-moderator will be Jay Simpson, President and Executive Director of ACEC New York. The last presentation lecture in this series will be on September 15, and that will be given by Jerry Buckwalter, Chief Operating and Strategy Officer at ASCE, and the lead of the ASCE Future World Vision. My co-moderator will be Terry Nickmeyer, Chairman of the Board at KCI Technologies. Starting on Tuesday, September 22nd, we will inaugurate a new lecture series devoted to the issues of social justice as they relate to the AC industry. Join us then and for the subsequent 8 Tuesdays into November as we invite leaders from the public and private sector to this new and important series. On our website, cbips.engineering.columbia.edu, you can find information about our past lectures, including the PowerPoint presentations and video recordings of the talk. You can also find information about coming lectures in the program. Recently added to the website are thoughts about the reopening of workplaces, in addition to the ideas about the reopening of restaurants and bar spaces. Again, thank you so much for joining us today, and please stay well. See you.
Thank you, Peniowski.
Thank you, Doug. Thank you, Lance. Thank you, Doug.